In this video, we'll use Excel to find a cubic trend line for the given data. Remember, a cubic function is also called a third-degree polynomial. So I've already graphed this input-output data. So we have our input-output table, which is the original data, together with the scatter plot of that data. To create the best fit cubic trend line, we click on any data point in the scatter plot. Then we right-click and select Add Trend Line. Now from the options, we need to select polynomial, and we need to make sure we select order 3, the polynomial of degree 3. So in Excel, that's polynomial order 3. Make sure that you also select Display Equation on Chart, and it adds the equation of the best fit third-degree polynomial to your graph. I'm going to go ahead and then click on the text box that shows that equation, right-click, and format the trendline label. I select number, and I'm going to round the coefficients in that equation to 4 places. Okay, so this is the equation of the third-degree polynomial that best fits this data. Now that I have a best fit trend line, I can now create an input-output table using that model. So I'm going to come down and create a new input-output table where we have the x values, and we'll find the predicted y values from the cubic model. I'm going to copy the x values that we originally used, and then I'm going to write an equation in Excel using that third-degree polynomial trend line. So I've created an equation that is 0.0466 times the x value cell cubed minus 4.1636 times the x value cell squared plus 86.2121 times the x value cell plus 1544.6154. I press enter, I drag that formula down, and now we have an input-output table that gives the y value predictions from the cubic model. Notice that the y values are fairly similar to the original data y values. So for example, in the original data, when x was 0, the y value was 1670. And in the predicted model, when x is 0, we get a y value of 1544. I can now take this new input-output table for our predicted y values, and I'm going to insert a smooth line graph to show us the graph of the trend line model. Now that we have this model and this input-output table, we can use it to put in other x values. For example, if I want to know the predicted y value when x is 27.3, I can change the x value to 27.3, and it tells me that we have a predicted y value of 1743.259318. We could also do the same thing using Solver. For example, if I want to know the predicted x value when we'll have a y value of 1400, that looks like it happens about right here, somewhere around x is 35. I put my cursor in the y value cell closest to a y equals 1400. I go to Solver. The y value cell is the y value cell closest to the 1400. I want to set it to a value of 1400 by changing the x value cell. I hit solve, and it tells me that if x is equal to 36.8346, you'll get a y value that's pretty close to 1400.